we've talked a lot about ATP being the energy currency of cells, but I want to dig a little bit deeper into that in this video. And as we'll see, when we go from ATP to ADP plus a phosphate group, we have a release of free energy. If we look at just the system, ATP's free energy is over here, but once hydrolysis has taken place and now it's ADP plus a phosphate group, the free energy has dropped by roughly 30.5 kilojoules per mole, or our delta G is negative 30.5 kilojoules per mole. And if you watch the videos on Gibbs free energy, this tells us that this is a spontaneous reaction. Delta G is less than 0, which tells us that this is going to be spontaneous. Now, when I first learned this, I was like, well, it's going to be spontaneous. Why wouldn't all of the ATP just spontaneously in all of the water turn into ADP and just release its energy as heat or whatever else? And the key is it has to get over this hump. You have this activation energy. It has to go uphill a little bit if there's no enzyme to catalyze it. And the reason why we have this uphill hump is that the way that ATP gets broken up is that you have to, if we're talking about a water molecule doing the hydrolysis, which is kind of typically what people think about hydrolysis, although it can sometimes be done by a different molecule. If you think about the water molecule, what needs to happen is you need this lone pair of electrons on this oxygen to be able to do what we call a nucleophilic attack on this phosphorus in this phosphate group. And while that happens, if that happens, it forms this bond, and then these electrons can be taken back by this oxygen, which gives its negative charge right over there. Now you might say, okay, this might make a lot of sense, but you have to remember, this electrons are negative and they're surrounded by these negative charges. So they have to overcome getting close to these things. So as they're approaching these negative charges, they want to repel each other. So you have to overcome that. And the way that's overcome is a class of enzymes called ATPases. ATPases, I guess is the better way to say it. ATPase. And what they do is, remember, these enzymes are these big protein complexes, and the ATP molecule can bind in the right place, and they essentially try to surround the ATP molecule with some positive ions. So let's say there's a positive ion here, so it can keep these electrons busy while the water or whatever is doing the nucleophilic attack can react, cannot have to worry about these electrons over here. So it might have a positive ion here. And remember, if we think in 3 dimensions, this thing is all wrapped around in different ways around the ATP molecule. So this is the ATPase. And so by having the enzyme over here, you're lowering the activation energy, and so it might actually look something more like this. And so the reaction can actually occur. So the reason why you just don't see this happening all the time without an enzyme is, well, you have to overcome this hump. But once you have the enzymes, they can actually allow the reaction to occur. So this attacks this, forms this bond, and now you say, well, you have another hydrogen right over here. You have another hydrogen right over here. But this could get nabbed up by another water molecule becoming a hydronium ion, which is actually what's going to happen. And then this character takes away this pair of electrons, becomes a negative charge, and we're left with that phosphate group has been broken off, and then we have our ADP, and we have a release of energy. Now, typically, you don't want this to just, release energy for no good reason. Most ATPases are going to leverage that energy, that release, this reaction, to phosphorylate a molecule. And in this case, you can kind of think that this hydroxide has been phosphorylated, but it might phosphorylate something else. Or it might change the conformation of this ATPase, so this ATPase, so it can do some other type of work, transfer molecules against their concentration gradient or their chemoelectric gradient, whatever it might be. You don't want to just release the energy. Sometimes that might happen if you just want to generate some heat, but usually you're going to do some useful work for the actual cell. So hopefully this gives you a little bit more appreciation for ATP and the reaction by which the hydrolysis can occur. And this is called hydrolysis because, at least in this example, we're using a water molecule to break it up, to take off a phosphate group.